Yo, 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 what's up, everybody? Welcome back. Today we are working on implementing OpenGL for my fake GPU. So context here is we've been kind of working on for the past little bit, trying to understand what goes into making a graphics card. We thought it would be fun one day to make one ourselves on an FPGA, but before we get there, we kind of should understand what does a GPU actually do. And to do that, I think that we have to kind of like walk through the whole software stack because there's a pretty like unclear line in my head about like what parts of GPU usage are done in software and which parts are done in hardware, right? Right? Like we kind of know that sometimes you write some OpenGL and like let's see if we can pull up an example here. Probably if we go into source QEMU. And go into our driver here. Yeah, so, we have like a vertex shader, right? And like typically you write some code that looks like, a little bit nicer formatted version of this. But like you have like a vertex shader and this says like for an object that I put on the GPU in OpenGL land, do this transform to that thing, right? So we have like this like transformation that we can apply to these like sets of vertices, and then we can like texture our output according to some sort of UV coordinates space things, right? So we can look at like test app here and we can kind of show like dev dri card one, sorry. So this is our like example app right now, right? We have this guy and he's rendering through we have like a virtual GPU who is rendering this thing through some like commands that we're sending through a kernel driver that we wrote for our fake graphics card that we also wrote as like a QEMU device. So what am I trying to say here? What am I trying to say? I'm trying to say that what this does is like very unclear to me, right? We have this like, sorry, let me stop this because it leaks memory. We have like this action that we've asked to perform on our GPU, and we have this other action that we've asked to perform. It's like something must compile this code into something that the GPU can understand, right? We can probably assume that there's some sort of like GPU assembly that gets uploaded to it in some way. There's probably some sort of like memory that we upload this like 3D graphics data to, but like I don't really understand at what level a GPU is working. And so what I want to do is I want to walk the stack from top to bottom and figure out what all of the software is doing so that if we were to make a GPU, we would understand what interfaces it needs to provide for the software to do what it needs to do, right? So what we have implemented so far, we have QEMU, which is a virtual machine, and in here we have our little PCI device that we've implemented. This is like a fake PCI device. Now, from the perspective of like our kernel driver, this thing doesn't know it's fake, right? So he has like a Sphero GPU driver who looks for this PCI device and talks to him. And what we do is we have like this app who talks to the kernel through like a known API called DRM. Oh my god, DRM. And he like basically we've implemented a few custom calls from our GPU or for our GPU driver that say like upload vertex buffer, texture, and transform. Right? We upload these three things, and then this gets like, he puts those into our PCI device, and then he draws that into like the QEMU screen on the other side. That's what we've implemented. Now, this kind of set of APIs here is completely ignoring like the normal graphics stack. The normal graphics stack is that someone calls like, essentially what we're doing on the host side. We're using OpenGL to render this stuff. We kind of want to push the OpenGL stuff down into like user space side, right? So our app should be calling like GL like draw arrays or something. That's kind of like the like end goal here, is that we have some way to like call into like OpenGL functions and use those to leverage hardware implementations of things to do something. And we just don't know what that means. So the goal for today is to start integrating with this project called Mesa. Mesa is like basically where the vast majority of OpenGL implementations for Linux devices lives. So these are like open source
user space drivers. That I don't know what they do. I just know that that's what it is. So we've kind of poked around the code base of Mesa a little bit in happy hours in the past, but have struggled to really understand what it's doing. And so I think that the goal for today is just try to integrate with this in some way, shape, or form. Or we can try to point it to our kernel driver. I think what it does is it looks. My guess is that it looks at objects in dev dri, and we have like card 0 and card 1. Card 0 is a card that Mesa knows about. So I type like egl info dev dri card 0. Nope, egl info. Maybe it's just egl info at all. He finds this like vert.io GPU driver, which is the card at dev dri card 0. And what we kind of want to do is basically have any form of like Mesa telling us that we see a Sphero graphics card. That's kind of the goal for today. And so I think we'll just kind of start. I don't really have much of a plan. Not much of a plan other than build it, find the entry point, and implement something. So we'll see how that goes. Is that the monkey from the GLSL tutorial? It's the Blender monkey. So we took the Blender monkey, we textured him, and did some like lighting baking, and then embedded that into our application. So it's not digital rights management. No, it's DRM for probably. I can't remember actually. I knew it very recently. I just can't remember. Did I lose my window? DRM Linux stands for Direct Rendering Manager. Every time I've looked into this, I get to the flowchart diagram. There's those big ass boxes that says Mesa 3D. Yeah, it's doesn't look simple. We'll figure it out. So a little bit of extra context here. There's all of these like OpenGL commands typically, right? You have like GL draw arrays or something. These are part of like the typical like OpenGL specification. There's also like how do you get an OpenGL context? And in the Mesa world, this is handled by a library called like EGL. And so this is probably where we're going to start looking. Is it like EGL stuff? Probably. But we'll see. So right now, Mesa in our virtual machine is built by buildroot. And we have like Mesa 3D cloned here. If we're going to start making modifications to this thing, I kind of want to track that myself. So what I've been doing for this project up until this point is kind of like yoinking source tarballs for different projects that I'm working on, and then like extracting them myself, so I don't have to like check them into the code base. So I think we'll just do something similar here. We will do something similar here. Well, we'll try to just yoink a Mesa tarball from somewhere. So here we'll do s busybox Mesa and s busybox Mesa. And oh, this is a bug in here. This should say busybox version here. Oops. I guess we'll leave it, but for now, because I don't want to break it. But it should say busybox here. And then what is our Mesa version? So let's kind of just get like Mesa 3D. Downloading. All right. I guess do we have like a like egl info help? Like I want to know like what version of Mesa I'm on. I guess we'll just pull whatever's latest. Okay, so what is our version here? It's 24.24. And I guess we have to implement some make rules to download that shit. So this comes from here. And once we have the tarball, we are going to extract that thing into a source directory. And I think that means if I type like make source Mesa 24.24, we should download that thing and extract it. And it looks like we have our source code. Big win. Big win. So we're gonna kind of maybe, how do I want to do this? The build rules are gonna be a little bit tricky here. So
I think that we need to point it to the correct compiler. So what does build root do here? How do I know? Build mesa. So can we look at the like Mason info here? How does he compile these things? He must just override like. We need to use the build root cross compiler so that Mesa gets all of its dependencies from the right spot. And we probably just need to call like Mason with some rules to do that. I just don't know what those are. Mason help. We also don't have Mason. I wonder if that comes from like build root target host bin Mason. Okay, that might be interesting. So if we just do like, how do we use Mason again? All right, how do we figure out what the fuck build root is doing when it builds this thing? I guess we probably like ask it to like make Mesa or something. How does this make file work? We should probably look in the source directory. That makes a lot of sense. Mesa 3D dot make. Does he like have like rules in here? Jeez Louise. Jeez, I don't like this at all. That's a lot of stuff. Crap. Is there somewhere where they said like CC? No. Jeez. Okay. Okay. What's the play here? What's the play here? Can we do something that's like fuck. So build root, when they do their stuff, they put a bunch of stuff in this like host folder. So presumably Mason will look for some dependencies in that folder somewhere, right? So when we did like Mason and he's like, yo, I can't find Mason build. Can we like, what type, is this like a Python file? What is this thing? Python. Okay. This is Python. So that means that we probably have to set our Python path to like lib Python, then run this. Okay. Now what? SRA module mismatch. Fuck, dude. I wonder if like build root is doing some sort of like bullshit ch root or something. We probably can use like system Mason. Let's not overcomplicate things. Okay. So if we do like Mason help. I haven't used Mason for a long time. Mason configure setup. And then setup, we need to give it like a build directory and a source directory. Okay. Now, presumably we need to tell it like library search paths or something. Library path. Oh my god, what just happened? Okay, env grep library path. Do I have that right now? No. So we can do like library path is equal to the build root staging target use a lib or something. And I probably want like CC. Maybe we just want like CC is equal to the compiler is going to be from build root host x86 bin bin x86 64 build root Linux cc. Okay, let's try that. And then it's here from source mesa. Jesus. Can we do like no such file or directory? Oh, okay, so that needs to be like absolute path. Okay. Now he wants package config and cmake. This is not what I thought this was gonna look like, to be honest, but it's okay. It's okay. We'll figure it out as we go. Okay, so now he's like looking for these libraries. So can we do like package config search path to like specify? What is it? Package config path. And here we want to do pud build root like target lib user lib share. Fuck. Okay, let's take a look. Build root staging. I guess it wouldn't be like installed. Maybe it's like under host build. Find dot dash iname package config. No luck. What about in here? There's host bin package config, but nothing else really. So how the fuck do they find their dependencies? Host include, host share, cmake maybe? Can we find anything that looks like what dependencies was it looking for? Vdpow, libgilvund, gl slang validator. Hold on. Okay. Oh, maybe it's trying to like build. Oh, god damn it. Mason cross compile. Is there like. Oh, it's so hard. It's so hard. Okay, you know what? I'm gonna do this off stream because this is a fucking pain in the ass. I'm gonna do this off stream, and instead, I think we might be able to get away with. What if? Hear me out. What if we just edited this code? This doesn't already configured. So if I do like ninja here, will that fuck shit up? That seems okay. Okay, so let's kind of start here. You know what? Let's just not go. And if I do like ninja install, what does that do? What does that do? Fuck. God damn it. I think that we can do something like if we go into the build root, I think there's like stamps in here that we can reset. Oh, it's so hard. It's so hard. I'm trying to think what's the fastest way to get what we want here. I wonder if we can do like a. Okay, so if I go into build root and I run make here, what does that do? Is that just gonna like fuck my shit up? Maybe. Okay, so that's pretty quick. That's pretty quick. And I wonder if we can like coerce this thing into rebuilding Mesa. So I think that we've seen before when we've been poking around this stuff that build root shoves these like little stamp files in here to mark that it's done something. So first of all, let's see if there's like a make mesa 3D. Let's just start there. I think that this is like, he's probably like just cranking CPU parsing make files. And it looks like that was a target. So that's good. And can we do like v equals 1 verbose equals 1 make mesa 3D? Is that going to help us at all? Okay, so that's interesting. Okay. Now this I think is again just cranking out make files, which is annoying. And if we do we see anything interesting here? If we go into build and we say like let's just put this as dot back. We'll say we didn't configure this shit yet. Let's see if that triggers a rebuild. Let's see. Because we need to get something. Okay, so that's good. So we have a way to build this project now. So that's kind of all we wanted. And it looks like there is 1,000 files to compile here. So it would be nice actually if we could see what he does at the beginning of this build and see if we can like trick ourselves into getting into that environment. So before he does anything, does he do like a fake root or something like someone in chat suggested? Okay. So yeah, he does prefix equals user. No, okay. And then he has cmakes prefix path is this stuff. And then does he like export the path? Here we go. So is this just the line here? That we just kind of like fuck up our path like this? Maybe. And then, dude, what is going on here, by the way? Why do I have like 1 million of the same fucking cargo thing? That's pretty funny. Okay, if I do this again and do like build text and this. Oopsies. Tmux attach. I don't know what the fuck I just did. Yeah, okay. So it looks like that's the command, to be honest. Yeah, so I think we can maybe even just copy paste this. User bin env bash. Like if we just fucking run this shit. All right, there we go. Okay, we have our fucking rebuild command. Sick. Let's take off the like -v on ninja builds. I don't actually want that. There we go. Okay. Sick. We have a way to build Mesa now after we modify it. Now, probably we could actually leverage this to figure out how to run Mesa or Mason correctly so that we can kind of work in our own project actually. I would like to kind of see that actually. So can we go back into build Mesa and take that configure stamp again and just kind of like remove that fucker. And then run that make thing again. And then I think I actually kind of want this to be like t build text. And we'll see how he runs Mason. And then so once we have those two commands, we can kind of like use those in our build root or like our thing. All right.
All right, we're getting closer, guys. We're getting closer. So I suspect this line is going to be the Mason command that we run. Jesus, what am I looking at here? So can we do edit configure? And let's just see, what the fuck is this? Okay. So can we like remove whatever my fucking shell script is doing is fucking doing something stupid. So I think I just want to do like s home streamer multi-rust tool chains. How do I do like a non-greedy search? I guess I kind of want to do like multi-rust except anything that is not a colon. Yeah, there we go. That's a lot better. And then there's also cargo. Sorry, let's do that again. So I guess we also want to accept a quote. There we go. That's a much shorter path line. And then we want to change this to use our... Do we fuck something up? Did we not copy the whole thing? It actually looks like we can probably just find till the quote. Just delete all this shit. There we go. There we go. Now, what else am I looking at here? So here we want to change these last two arguments to be our source and direct our destination. So this is source mesa into our build mesa. Okay, let's just see what happens when we do that. I guess we now need to make sure that we're building the same versions. I think they had 2409, I think is what we saw there. So we should match the version so that we don't get confused. So let's just do a little bit of this. Okay. Okay. Hold on. He still doesn't like that. Oh, but he's still using the wrong source directory. The fuck? Oh, because I'm using the raw... I'm fucking downloading from 2404 still. Hold on. This should use Mesa version. And so should these other guys. But we'll come back to this later. Okay. Let's try again. Much better. Okay. And then now can we try running our configure script again? Oi. Still no good, huh? Still no good. All right, fuck it.
Fuck it. We'll just go back to running our build.sh like good little boys. We won't try to use our own source directory because we can't fucking get there. It's too hard. Fuck builds. But I'll try to tackle that offline. We have wasted too much time on this. We will build the version checked out by build root and then just go behind build root's back and change the source as we go. And then hopefully he's okay with that. We will build this once, just with the typical shit. And I would like to, just set this up in a way where we print literally anything so that we can prove to ourselves that we have really done something interesting, right? So I don't really know how to do that right now, but we'll figure it out. So I guess we kind of need like a little test application that tries to do some sort of like EGL initialization. Probably. So let's maybe I think we have a sample EGL initialization file in our Sfoyland client. I think under GL helpers, we have an EGL context initialization. So I wonder if we just kind of yoinkies this file, maybe even just this, maybe even just this. Let's just kind of call like one function and like see if we can do something with that. I like that. So let's copy this to the system clipboard and make like in our test app. We'll kind of just go like right up front. Let's just start here. So this is EGL, I think, EGL.h or something. So does this build right now? We are not in the right environment in this terminal, so let's get there. Let's get there. I guess this would be easier if we didn't have to do our development like cross-compiled for a virtual machine, but we've kind of made our bed, as they say. Okay, so he doesn't like that I called that GL dot. That's fair. It's C dot here and Zig build here. Okay, so now he says there's an undefined symbol. So in our build Zig, we need to link system library EGL. Okay, cool. And let's just make it so that we can like SCP that thing. Here, I think we need to turn on networking in our virtual machine. We copy our program into the virtual machine, we run it. And he doesn't crash, which is great. And now what we want to do is we want to basically figure out if we can modify that. So that we'll just try to put a print and EGL initialize just to get started. Is everything here absolute paths? I think it is. So I think it's fair for us to copy this move build.sh into build mesa 3D 2409. Okay, and then if we type build here again, he's fine. And then let's just look for EGL initialize, right? That's somewhere to start. Where the fuck is this? Here we go. EGL entry point. The fuck is this? This is in EGL entry point.h. Dude, it's just finding the fucking function's not trivial. It doesn't exist. It doesn't exist. Oh, here we go. EGL API. Okay, printf. Hi, Mick. Right? We run our build.sh. We see that he recompiles source libegl.so. We're going to hope to God that we've dynamically linked this thing and try to do something like let's find libegl. Okay. So we have this 100 thing in here, right? So we should be able to do like scp build. Find build libegl star. Okay. SCP. What's our SCP line? It's like SCP dash port 5555. We are trying to copy this thing into user lib. This thing, right? So we're trying to overwrite it. And then we copy from here. Okay, so now if I run test app, we don't see anything. So I was really hoping that we would see this. Really hoping we would see this. But it looks like we do not. So the question is did the test app we built here? He does look for libegl.so.1. Okay. So there's a couple options here. One is that it doesn't, this isn't like the right libegl, right? That's a possibility. The other option is that this is not actually called here. I guess the other option is that we didn't call egl initialize. We called egl get display. So that's hopefully the actual mistake that we made. So let's put a printf HIMIC here. Do the same little build trick. Oh, okay. Big win. We have built Mesa. It took us 30 minutes, but we got there. Since you're on KD, you're using Wayland or X11? We're on Wayland. Okay, so let's try to find the entry point for our driver, right? So theoretically, let's try to write a little demo app that prints out the driver name, right? So if we can print out the driver name, then we should be able to start tracing where the driver is initialized, right? So what's our example? Swayland client source GL helpers. Let's just kind of start here. So here, let's just kind of rip all of this just to see if it fucking works. So let's kind of just do here. This is basically what you would usually do for a surfaceless EGL rendering context. At this point, all OpenGL commands should work theoretically. But, you know, let's just see. So we'll do the same, like zig build and run our test app. So he's failing on EGL init. Which is pretty interesting. So how do we do like, can we print out like what it's failing with? Because like here we aren't even trying to use our driver anyway. We're literally just trying to initialize EGL. So can we, what is like EGL initialize return here? Do I have like a browser window open? Am I fucking high? I must have closed it. Yeah, I did. EGL initialize. Best thing about the channel, running complex low-level projects and just stumbling to solutions, which is much more relatable and educational and scripted. Let's build this OS in 2 hours stuff. Yeah, I mean, we are pretty out there. Bad display is generated. So this just returns false and doesn't tell us why. Oh, maybe we need to ask for like EGL error. Yeah, EGL get error. This sounds familiar. Std debug print. What error do we get? Zig build and copy. That's annoying because we didn't write new line.
Okay, and then does this like... Here, oh, here we go. Can we print it as hex? We need to print it as hex because those things are in hex in the header. Let's just see. Let's just see. 0x. Okay, 3001. Okay, 3001, which is not initialized. That's really great, guys. So we're like, hey, could we initialize? And he's like, not initialized. Great, cool. So maybe EGL default display is not the way here. Can we do like EGL get display dev DRI? I guess there's another project that we've been playing with called KMS Cube. And I bet KMS Cube, here, we can probably show here. If I like open up this guy, and I say KMS Cube -d dev DRI card 0, what this does is he starts like rendering a GPU with forwarded OpenGL calls to the host through like an existing driver, not ours. But we could figure out what he's doing when I pass in that, how he initializes EGL. So he does get display with GBM KHR, where this is a GBM device. Fuck. Okay, can we look up for like EGL get platform display? Like, what are our options here? What are our options here? Okay. Does this define platforms? EGL get platform display dev DRI. Surely somebody's asked this before. This isn't what I want. Headless EGL. OpenGL headless on Linux sample program. Okay, what does this guy do? It looks like he might be using that. Okay. He does an EGL context, which comes from libegl EGL context. Initialize on device. Okay. This is too complex. I just want like a really fucking simple like get platform display. EGL get platform display for dev DRI. This sounds like the type of thing that the idiot's good at, to be honest. Could you give me a sample application that initializes EGL with get platform display using dev DRI card 1? So he opens the file descriptor. Is this real? Is this like reasonable? Platform device X. Let's see if that exists. The only valid platform is device X. EGL device X object. Okay. So, so far, not guaranteed to be fucking stupid. I'm down to fucking try it. I mean, it can't hurt. It can't hurt.
Well, it could hurt, but, you know. We might as well give it a shot because what we're doing obviously isn't working, so. How do we do this in Zigland? We want kind of like U64 FD is equal to, so we can just like open the file, I guess. Which kind of means that we should do this, all of this stuff should come after we have opened the file. Which we kind of do down here already. So we'll just kind of like copy paste this shit a little lower. Okay, which means that now we have like U64 const fd U64 is a U64 is equal to f handle. Okay, so that allows us to do EGL int has got to be small. Let's just do f handle here. Okay, we need to define this as like a bunch of attrs. So we have attrs is a array of cegl int is what he said. And then we have a var display is a EGL display. No, we can just do const here. There. Sure. And then here we pass in f handle again. Let's see if this does something. Let's see if this does something. EGL platform device X does not exist. Oh, because I think we need to include like EGLX as well. I think. Expected any opaque found I32. Right, so we need to sign extend the handle. FDU64 is a U64 handle. And then we pointer from int from FDU64. I think that's how they want it. Okay, then we need to like int cast this. And then attrs here needs to be a slice. He's mad because he expected type const. I'm confused here, to be honest. Expected type C pointer to const I size found 3 I sizes. Okay, so we put ampersand here. Oh, here we go. Error no display. Okay. Oh yeah, I guess kind of doing display the way we were doing it before was actually getting a display just fine. Also, it looks like ChatGPT is like a fucking liar. To be honest. Fuck. Fuck. It was worth a shot. So I guess the display was opening. So maybe we go back to using the default display and, well, EGL get display. And it was C EGL default display was what we had here before, I believe. Yeah, so that actually gets past the display opening, which is interesting, I guess. So maybe we can start looking at what do we actually return here? Does this go anywhere? Wrong file. Sorry, I'm trying to go back to Mesa. EGL get display. Or we can look for hi mic, I guess. So what actually happens here? What actually happens here? He tries to initialize a specific driver for a given display. Oh, this is EGL initialize, fuck. Sorry. Get display. So what happens here? This gets pulled in from EGL default display, right? That's what we saw in there. EGL default display. So where does that come from? Who fucking knows yet? Who fucking knows? But he gets a pointer from this thing. Probably EGL default display is 0 would be my guess. That would be my guess, is that this is a special null pointer. Yep, null pointer. So he in here is going to look at this thing and be like, am I a null pointer? Would be my guess somewhere. Ooh, hold on. This is interesting. So he looks for a platform type. I would love to get into EGL platform DRM here. I would love to. So can we, at the very least, print out the detected platform? Let's start there. Let's start there and we'll work our way up. And then I guess we will SSH -p5555 root at local host, and we want to run test app with dev DRI card 0. Detected platform -1, which is invalid platform. Okay, so we end up in here. So here he's trying to figure out our display type. Which looks like he's just going to return invalid platform. Right? That's kind of what it looks like. Detected platform -1. And so then it turns into native platform. Oh, and then how do we turn on these EGL logs? That sounds interesting. How do we like mesa EGL logs? There's going to be some sort of like EGL debug, mesa debug. Okay, we can try that. That's not the one. So I want to know, like, who decides where this goes? EGL log level? Aha! Native platform type X11 build time configuration. So that's not what we want. Not at all what we want, right? We want it to use dev DRI. So how do we do that? There is this like get platform from env. So let's look at like EGL platform. Here we go. So EGL platforms here. We want DRM. Oh, okay, wait. That looks good. It looks like it found something. Nice. Okay, so there our app actually doesn't crash, which is really good, actually. Our test app didn't crash, which means that it got through all of this. Now, it looks like there's also the ability for us to specify a display as well by default. Right? There's EGL display. Oh, that's deprecated. Okay. How do we get it to pick which card then? Right? How do we get to pick which card? So here we're going to be on... Sorry, let's look again at this code. So we have a detect platform, which means that we're fucking chilling at this point. So that means the caller of this, which was, fuck. Here, we then call get display given that thing. So I assume that the display would be which card, right? We have like card 0 and card 1. That's my assumption here. So how do they do this? Maybe not get display handle. Okay, maybe not. So how do we pick? Maybe there's like many configs here. It would be interesting to see how many configs exist in this thing. Let's turn back on EGL debug there, actually. Because I think there was some interesting stuff that came out of that. Oopsies. Right, like, does this say anything about, like, configurations? Okay, so we see this. Mesa loader calls vert GPU DRI.so. Right, so where does that happen? I guess we can look through their source code. What was it? I already forgot. Vert GPU. Let me just look for this. Okay, so we see for each D, gallium DRI drivers. Maybe in here. Vert IO driver descriptor. What's going on here? Okay. So this is in gallium DRM helpers. No. It does seem like this is probably related. Probably. I mean, there's only a few places in the whole project where this string shows up, and it's really in the build config here. So we gotta figure out what this build script is doing. Like, gallium, if for each D in this shit, if this is true, then he appends vert IO GPU DRI into this thing. And then he loops these things, and he has custom target for this, which looks like it's generating some code here, which is going to be a pain in my ass. So it looks like he probably like loads something off the file system. And then spits that in somewhere. Asahi is also in here, which is the Apple GPU. Oh yeah, pretty cool, pretty cool. Okay. So someone libgallium DRI is like some shared library shit. And install mega drivers. Gross. Okay. That's. I guess we could also look for the log. When he logs that, we could look for where that is. Right, we could look for mesa loader in all caps. Here. So can we look for like a call stack here? Presumably backend from driver name, DRI2 open driver. Create screen for driver, screen create, device create. Why is this changing as I jump up? There's a bug in here for sure. But it looks like GBM create device in EGL native platform here, somewhere along these lines. Is interesting. Okay, first pointer. He doesn't actually do anything with that though. Someone calls. I forget where we were. It was like loader open driver. Okay, can we look for like DRI2 initial? I don't like that my fucking call hierarchy is broken, man. That's so annoying. Yeah, it's really fucking annoying. Really fucking annoying. Okay. It's fine, it's fine, it's fine. It's fine. It would be nice if we had GDP, but I don't think we do in our like guest environment. Like, why would we, right? So I don't really know how to deal with that. I guess maybe we could like kind of get out of the. We could like do this work on host first, and then kind of like translate into the DRM stuff. But I think, or like translate into like the virtual machine environment. But I think that's harder. Let's just check. Let's do like a little if true return here in our app, and see if we still get that log. No. Okay. So what about on EGL initialize? Why is this failing all of a sudden? Oh, because we need fuck. We need this like env shit. So we want fuck. Where was it? It's this. Env, copy all of this. Copy, please. Copy. We need this env shit here. There we go. Okay. So when does he call that function? It's on EGL initialize. Somewhere in EGL initialize, he is resolving vert IO GPU, right? So let's start there. EGL initialize. Hi, Mick. Okay. So what's going on in here? Loader, driver, override, Gallium HUD, always software. Okay. So none of this really seems like we want. So probably it's going to be in the EGL driver initialize here. So EGL driver initialize with this display. How does this get set? Looks like probably in here. would be my guess. Yep. However, we are seeing this kind of the mesa loader stuff come before, unless like the standard out is like coming out of order. In fact, we can kind of assume that it is. Maybe not. Right, because we saw like if we move this if true return back, yeah, so there's some sort of out of order shit happening here, which is going to be a little bit of a pain in the ass. I guess maybe we shouldn't be using printf, but we should be using their logging infrastructure, which would probably help. Right, so if we do like egl log egl debug or something. Here we go, like this. Then we will see it in order. Yeah, here we go, nice. Nice, we'll do it that way. So, how? I mean, here we're clearly in DRM, right? Yep, we still see it. Then we go into here, and somewhere they must try to resolve which platform they're on. So here can we say like device active, and we'll print here like checking GBM. I'm just trying to figure out like where the fuck we are in here, you know? Checking GBM. Okay, so this is not null, it seems like. Because we don't see this. Well, maybe we don't know. It's null. Oh, so it is null, but we don't have a display device yet. So we're probably in this else case. Opening vice at this. Nice. Okay. So here this is hard coded as dev DRI card 0, it looks like. Dev name. %s card with a argument. And then this gets dev DRI. Yeah, so it's hard coding 0. It's hard coding 0. Which is a little annoying. It seems like it would be nice to not hard code 0. But here, what's going on here? This DRM nodes thing, it looks like there's an option for us to override by forcing a device. Kind of hand wavy. Right? So if we use platform display and we force it somehow, that's possible. Right, so that's kind of what we were seeing at some point. So, well, maybe it would be nice to force it. So, EGL, we're going to go back. We're going to go back to trying to force a specific card. So, EGL platform display GBM, it sounds like, is what we're trying to do here. Okay. This looks a lot like what we want, right? So we want to open the file descriptor with our specific card. Then they call GBM create device. and then they use a GBM platform device. Okay. So where does GBM create device come from? GBM? You know, fuck it. I guess we could even look for where that thing is in somewhere. Build root, target, host, include, find dot dash iname gbm.h. No. Target? No. What is this? GBM. libgbm. GBM front end. I don't know about that. I don't know. I don't know. Where is this defined? libgbm. So are we not building libgbm? That's a little annoying. Another abstraction layer? I don't want another abstraction layer, man. Okay. So from a GBM device, set to GBM mesa, must point to struct GBM device. All right. So are you saying that this is not part of the fucking mesa project? Oh, it is. It is. I guess. Unless GBM is like... Okay. Hold on. So are we just not building this part? Mason... Oh, we are. libgbm, it's here. Okay. So that looks promising. Can I make sure, like, what happens if I type install on that shit? He doesn't like that. So we'll figure it out. We'll figure it out. Okay, so include source GBM main gbm.h. We could just like fucking run at this shit manually, but I don't really want to. How do we fucking find dot dash iname gbm.h? It does end up here. Okay, so we probably can link against it. We probably can include it, which means that we can call gbm create device with the file descriptor. And it does look like this resolves, which is good for us. Then we should be able to call get display with gbm dpy. Right? I guess technically it's better to do it with the extensions. So let's do that. And let's just kind of see what happens there. He doesn't have that. So can we do it the other way? Just kind of see what happens if we do this. We probably have to link. GBM here. Okay. So now if we do card 1, he uses software rasterizing. Sick. Okay, wait. That's really good. So we now have, like, at the very least switched behavior depending on which card we are trying to use. And let's just kind of move on with our lives now. So this is an EGL initialize. I kind of lost where we were here. I'm not gonna lie. So let's try, where the fuck is EGL.h? It was in some C file, right? EGL initialize. Here. Yep. Okay. So we end up somewhere with the right display. I want to go back to wherever the fuck we were. It was like DRI. It was in initialize. I believe this was like kind of bound to DRI2 initialize, right? And did we see... We do end up in DRI2 initialize, so we're in this function, which we probably end up down here. And probably now GBM is not null, right? We're probably in this path. So say using existing GBM device. Build sh and run this. Okay. Using existing GBM device. Sick. Okay, we are getting somewhere. Now, somewhere down here, he's got to resolve something. Like the driver for the card. So here, can we look at this? EGL log EGL debug. Driver name is this. Okay. What we got? Driver name vert IO GPU. Okay, so where does this get assigned? This comes from DRI screen create for driver. Okay. Which comes from this. Okay, so what if we run with card 1? This turns into software rast. So whoever calls this with software, probably, it's probably here, right? They probably try to call this thing. It doesn't, they try to initialize this thing. It doesn't work, so they initialize the software, and we can check that. So here we can go EGL log, EGL debug, failed to initialize. We'll just kind of do this, I guess. Oh, he doesn't like this. Why doesn't he like this? Is it because we're not in EGL anymore? Is there any like way for me to log in this? I guess we'll just printf then. It's fine. The log will come out late, but we'll live. So that is not the case. That is not the case. Here we'll say software rast here. We don't see that either. We also see an attempt to open Sphero GPU DRI.so, which is kind of interesting. But We will see somewhere if that is relevant. Okay, so where did we say driver name here? So we're looking for somebody who initializes this thing. So, Oh, it was here. Sorry. This is the one we want. So can we say here, EGL info or log? No, printf creating screen with name this. Does not seem to be the case. I wish we could fucking use a debugger. That's probably a thing that we're going to have to look at some point. Oh, we're also probably only copying libegl, which probably is not helping here. We probably need to copy more than one file here. Right? Certainly. Certainly. Because this is in source GBM, so presumably this comes from libgbm. Right? So we probably need to give the same SCP treatment here. Probably want to copy this thing into here. Right? Ah, nice. Nice. Okay, here we go. So creating screen with name Sphero GPU, creating screen with name software Rest. Nice. Okay. So where was this called from again? So our suspicion was here, right? Printf failed to create screen with create hardware screen. This was our suspicion. Nice. Okay, nice. So they try to create a normal screen. They get the driver for the file descriptor. Driver comes from loader get DRI config driver, which asks for the DRM version. So here he's getting the name of our driver. So here we should see using driver %s for %d. So it should say Sphero GPU for something. But I think that this log function can we just replace it with printf for now? That'll be easier. That'll be easier for a second. Yeah. So they see that we are using, they are looking for like a Sphero GPU driver that they pull out of our kernel driver name. And then here, they parse config files looking for that thing. So how does this work? So kernel driver name gets passed to user data, which comes from DRI rc.d or something. DRI rc. So that should be somewhere like in our thing, right? Find here, probably in user. Yeah. Okay.
Okay, wait, hold on. So we go into this folder and we cat that thing. And this is an XML file. Okay, wait, whoa. Why am I seeing fucking game names in this thing? Okay. Is there like a cd build find dot dash iname dirc? Nope. So this thing must get made like on install or something. But maybe we look for the content of the XML file we're seeing. So can we look for something that's like, you know, just like valheim mesa defaults? Right, because this is the file in the folder. Okay, so in here, can we find anything that looks like vert io GPU? Okay, we do. Okay. So where were we right like a second ago? Parse configure. Okay. Oh, so this is given an application name. No. Okay. So in this config-dir, they probably iterate all of the files, right? Parse one config file. So he creates an XML parser, printf, parsing, config, this thing. Okay, yeah, so he does parse our config, and as well as etc dirc. Doesn't exist. Okay. Okay, so in here, does anything interesting happen? I guess he just like tries to check if it's valid, like he creates a thing with start element and end element. Okay. Sure. This doesn't really seem too interesting. I feel like. We can kind of assume that this was probably just okay, and they check the options for DRI driver. So here, this return, what is the return here? DRI driver. And I see. So they're loading this config to check if we overrode the driver or not. Right? So here we say print, which we certainly didn't. Right? So I think we just kind of ignore this for a second. So it oh no, right, because here we were trying to see how the fuck does kernel driver end up as the DRI driver name. Right. Okay, so this gets parsed into user data kernel driver name. Okay. Then what? Then they check the options here for the DRI driver. I see. So user init options comes in here. Cache. And then in here, they must at some point set the DRI driver name. I see. So this must get used like kernel driver name is only used here, it looks like. That doesn't sound very interesting. Can we look for like the string name that they're pulling out here? I saw somewhere they have like, we're looking for the
DRI string. Okay. Is that like in that config file? No. All right. I'm not sure how this gets propagated, to be honest. But we should be able to at least printf here. Got driver opt, right? Let's at least see DRI check option driver. Right? Let's just at least see if that looks like something sane. Whoa. Why does that not work? Printf DRI driver is this thing. DRI driver. Oh, did I not new line? I did. Okay, so does that mean that this returns null? Directive argument is null. Do I have to do like null or do I have to do something like this? Is that what it's supposed about? Yeah, it is. So here he's like DRI driver definitely null. Definitely null. Okay, so we return this thing with null, which means that this isn't where he figures it out. Ah, so we're probably in here. No, PCI driver. This. Fuck off, dude. So PCI driver nil, and they use the kernel driver name afterwards. Yeah, I see. So this is kernel driver is this. Yep, okay, understood. Understood. So they use this DRM version thing to get the name. Understood. Where were we calling this from? DRI create screen, I'm pretty sure. This sounds right. So we get this name, and they create new screen. Check if the driver name is matching so that non-Mesa drivers will not crash. Where did this driver name come from? I forget. Here. It was here. So this is on initialize DRM. They set the driver name to come from the GBM driver name. Which we found was like through, I think that we don't know, I guess, where that comes from because GBM DRI came from initialization, but it's fine. We know that that is our driver. Okay. So create new screen could be the way. Presumably we're in here somewhere, right? Presumably. Printf creating screen. creating screen by Mick. Right, let's just see if this is where we are. It does not look like it, huh? Creating screen with name Sphero GPU is probably where we want to be again. Creating screen with name here. Create screen for driver. DRI open driver. This looks likely to be the failure point. Aha. Yes. So probably here. Printf opening driver for %s. Okay. Start there. So we see, oopsies, opening for software Rest. But before that, we see an opening for Sphero GPU, and that fails. So presumably this is what fails, right? Failed to find driver. Right, we can probably assume that. Failed to find driver. Yep, we see that in the logs, which means that this is failing. So he's basically looking for a shared object named after our kernel driver. Named after our kernel driver. So I guess that means we have to figure out how that thing is built, right? That's kind of the only thing that makes sense here. So we know that it's succeeding on like KMS SWRS, right? So like, right, it's SWRS DRI. Which again only shows up in this like build script. Right, so we really need to look at what the fuck this does. So he does an ln-f force input to output. So the output here, so for each gallium DRI driver, they have output is D. So the output is the driver, and the input is libgallium DRI. So these are just all symlinks to libgallium DRI, would be my understanding from this. Right, so if we copy this, no. Oh, but ln is hard link as well. So it actually could be. It could be. Can we do like a KMS for SDRI as well as vert IO GPU DRI? Ah, they're the same file. They're the same fucking file, baby. They're the same file. Okay, so we can get a little farther. We can get a little farther if we do Sphero GPU DRI, so like this. Right? Theoretically. Okay, so this didn't seem to do it for us, interestingly. Opening driver, but opening driver now succeeds when it didn't before, but they still says failed to create hardware screen. So we made it farther. So creating screen with name, do we see that? Yes, opening GRI open driver was where we were. Loader open driver, I think. And we saw opening driver. Okay, so here, fuck. Can we go here and say printf got no extensions? Or we will say yes extensions. Okay, solid. Copy paste seems like so strange, but I guess that's how it works. I mean, so I think that they're probably somewhere down the line, it's going to resolve within lib gallium which driver to use. I believe. We'll see though. Right, because probably this driver name is going to get used more somewhere else, but I don't know where. So I guess we should also check, does this fail? DRI screen create. Yes, we know that this fails. We know this fails because we're in this path here. So where else can it fail here? Fail to bind extensions. Hold on. Oh, it says no extensions here. Sorry, no extensions. It says yes extensions on the other path. So this is where he's failing, in here. Loader open driver. So we did not fail to find the driver. But once we do find him, then we have another problem. Get extension's name. So can we printf here? Sorry, where can we fail here? Driver is null. Extensions equals null, then we have a problem. So this is extensions. Driver, do we see driver exports no extensions in our log? We do. So presumably this is probably the important piece here. Get extensions name. So let's see, this is... Okay, so he's constructed a name here for DRI driver get extensions Sphero GPU. And presumably when he tries to open this thing, it's null. Yeah, because we see this log. Okay. So can we find DRI get extensions? Hold on. So this is like trying to search for the symbol in here. So that means that we should be able to go into like our build directory and find lib gallium or something and look at this thing and look for get extensions. Okay, so there's a symbol in this shared object that defines names for these things. Okay. So now the question is get extensions, I feel like is like a word that we should be starting to look for in lib gallium, right? So we're in source gallium in here, right? And DRI, wait, what was the function? I already forgot. Let's just search for this. Aha! Here they define it with a macro. Those little tricky motherfuckers. Okay. So here they define one for vert IO GPU. Okay. And what does it do? It just returns gallium DRM driver extensions. So if we were to go in here and we were to say Sphero GPU, we would get farther. Right? Surely. Got extensions. There are no extensions. Fail to fuck. Wait, that doesn't feel right. Right? Because we defined Oh, wait, hold on. We need to update our hack. We need to update our hack. So now we have another SCP, and it is of the build source is from here. Build source gallium thing. This needs to end up at wherever the fuck this is. User lib dri sphere GPU dri. So fuck. This needs to go to root at localhost. Remote makedir failure. Because the SCP. Oh, I don't see the problem. Oh, and I guess I forgot a little and in here. Okay. What the fuck? Oh, there we go. Okay. So now, yes extensions. Yes extensions, baby. Let's fucking go. Let's go. Okay. So we still do fail to create the hardware screen, but we're getting farther. We're getting farther. Because probably we shouldn't see this driver does not expose anymore. Now he just has driver missing. KMSRO driver missing. Okay. So how the fuck are we ending up in KMSRO is a little confusing. Because we never create our driver stub. It's maybe the last one that they iterate. Maybe they just like fucking give up. So DRM driver descriptor. Where does like these get used? I think I saw a list of these somewhere. Right? Like where are these used? Here. Yeah. So he tries to look for them and then he doesn't find ours. So here we must have to put in a Sphero GPU driver descriptor. Like this, right? Right? And we must have to define this thing. So driver descriptor. All right, so this looks like where we're supposed to be, right? They have, if we define this, then here is our screen create function. So let's just kind of do like a fucking, we're just going to send it here. There's no Sphero GPU in here, so let's just kind of like make one. So we're going to say like Sphero GPU create screen. And in here we'll return screen and we'll just say, hi mom, we finally, she called me back. She finally called me back, right? Because they're calling us. And we can say she's a she. And then here we need a DRI conf. What the fuck is that for? Does everyone do that? No. Looks kind of like they do. Here they just write null and 0, so we'll do that. We'll do that. And then we need Sphero GPU, and then here we typoed Sphero, which I assume is relevant. And let's build it and run it and see what happens. Fuck. Probably here we need to be like Sphero GPU driver descriptor exists. What did I do wrong here? Driver Dravir. All right, let's try that. Let's fucking go, baby. Let's go. So if we just like, let's just get crazy here. And we'll say, let's return some cafe food. Probably this will crash now. Yes. Okay. Okay. Wait, that's really good. That's really good. So we're only failing now because this function returns null. So I guess the next thing that we would have to do is figure out what the fuck this thing is supposed to do, right? But I think that's gonna be like, look at this. Look at this. This is the fucking driver, right? This is the fucking driver right here. This thing says like, here is my callback for getting vendor. Here's my callback for getting device vendor. Here's my callback. Like, this is the fucking driver, dude. So I think that we have finally, after 2 hours of spelunking and poking and prodding, figured out where the fuck we are supposed to implement our code. So that's a pretty big win for us. Pretty big win. And I think that this is a good place to call it because it's 3:52, which is just before the usual 2-hour endpoint. And I think that this is kind of a nice little place to call it. So I hope you guys enjoyed this. You know, it was a little bit different than usual, but I think at the very least shows how I would tackle a problem like this. Well, not how I did tackle a problem like this. I think that there's a lot of bullshit that we kind of had to spelunk through to get to where we wanted to go, but we did eventually get there. You just kind of keep slamming your head into the fucking wall, and eventually you kind of push a hole through it with your forehead, right? So, pretty excited. We'll be back tomorrow, and I think tomorrow's task will be to just try to implement anything. We don't know what a pipe screen is yet, right? But at least we know, at least we know how, not even how, we have found a location where we could insert code, and it does something, right? So presumably this pipe screen is the important piece, and we'll be back tomorrow and try to figure out how the fuck that thing gets used. So if you like what you saw, we stream most days at around 12:30 Pacific time to 4 o'clock Pacific time. 12:30 to 2, we kind of do like, we call it happy hour, and it's like kind of like supplemental content. So today we were shooting the shit, talking about foosball, trying to figure out, we were like doing like driver cleanup from our stuff that we were working on yesterday. Tomorrow I would bet that happy hour will involve trying to figure out how to like fucking check out Mesa and build it in a way where we can commit that. Maybe I'll do it offline, in which case we'll do something else. But, you know, it's like not like new features. You can kind of track the project without happy hour stuff, but the happy hour stuff is there if you want it. The only problem is it is paywalled on YouTube and Patreon. So if you want to see VODs of those things, check those out, or you can catch them live at 12:32. 2 to 4 is like the mainstream, and those go up to YouTube. If you're watching on Twitch and you're new around here, there's a YouTube link in the Twitch description. You can check out all of our previous playlists for all of the projects we've been working on. We're working on this virtual GPU driver right now. But, you know, we kind of cover whatever the fuck we feel like is like the trend. Source code for this will end up under the GPU testing environment on GitHub eventually. Today's source code is kind of just log, so this source code won't. But like whatever we are working on will end up there. What else? We say to like and subscribe and to Twitch Prime. And with that, we will leave off with the YouTube viewers, and Twitch, let's find someone to raid.